talking about shifted stuff. So, anyway, so you've got your two generic forms. One thing I want you to see is that your B value is outside the parentheses. So sometimes, worst case scenario, it might just say sine, then immediately parentheses 3x minus 3 pi. It means you have to factor out your B value. That's like the worst case scenario on some of these things. Oops, I did. Put in the plus K here. Basically, your H and K, horizontal and vertical. I know. You'll miss this. It is super fast and easy to work with these things. As you guys noticed yesterday with the fractional stuff, it's kind of the same deal. And just go from there. So let me show you. Oh, it's just right there. You don't have to worry. The rest of it's all, H and K are all the same. What I want to do is just kind of jump right in and say 4x, and then we'll just do we'll do a plus pi over 2. So we'll have y equals -2 plus 3 sine 4x plus pi over 2. Might as well just put it all into 1 right away. Remember, the textbook likes to put, if there's a minus k value, a negative k value, a lot of times they put it up front. So it means the same thing. The reason why they did that with this one is because the original problem did not have an h value to it. It would have looked like the h, yeah. A lot of times what will happen is, if there is no h value and there is a k, they put the k value up front so that it doesn't look like it is playing the role of an h value. H values will always be grouped into a parenthesis, just so you get it. Just like it was pretty much regularly with everything else. H's usually get grouped into a parenthesis. Okay. Gee, what do you think I'm going to do first? Write all your things out. Exactly. That never changes. Never changes. A, B, H, K, amplitude, period. Okay. Not really. When we get to the shift stuff, we don't get too crazy into that. Okay. What's your A value? B gives you an amplitude of, a period of. So your period is pi over 2. What's your H value? Good. You caught that. Negative pi over 2. And then your K value is. So this tells me, with my H and K, I'm going to take my X value, and I'm going to move it where? I'm going to move it left pi over 2. I'm going to move it left pi over 2. And my Y values, I'm going to move it down to. I like to put that on there because then when I go to doing my whole work, I know what to do with all my ordered pairs. Those ordered pairs are going to be the ones that you create from the parent function. You'll have them right in front of you, and now you know how to move them. All right? It's just putting down on paper a little bit of extra information for yourself helps you out in the long run. Because it's not that these, you saw last night. It's not that these take very long or anything like that to work with, but with so much extra information that you can get thrown into it, you mix something up here. You're not careful. Pretty much. Yes, sir. Yeah, and that's where we're getting at. So now, when you know where your shift is going to go from the original, I know I'm going to have to move it down, and I know I'm going to have to move it to the left. So what I do when I go to make my T-chart, I move the original part to the left a little bit further, and I bring it up because I know my shift is going to move downward. Just that way I have space work. Does that make sense? You just kind of start thinking of where it's going to wind up. Excuse me. This was what, a sine graph? Okay. So first thing we're going to do, we start with our period. We have 0, and it's going to end at pi over 2. Break points. What's half of pi over 2? Half of that is? Did you guys realize last night when you did these, breaking them into fourths, the closest one to the 0 was the common denominator for the rest of them? You realize that? 1/8, 2/8, 3/8, 4/8. That's how that works. If you didn't pick up on that, that's fine. Okay. Our A value was 3, so I have to go up 3, down 3. So it goes up, down, up. Then it looks something like that. Remember, this is a parent function, so we use dotted. And now this is, I like to write out my ordered pairs. 0, 0. And then by already writing down what my shift is going to look like, all I have to do is just add or subtract, especially with the fractions. So with my x values, I have to subtract pi over 2. So this is real tough. What is 0 minus pi over 2? Remember how you were asking yesterday if we've got to ever have to go to the left? This is where it comes to go. All right. What's 0 minus 2? I know it's not even 8 o'clock, but I'm asking a lot right now. You know what? You're wrong.
I gotta call them out like that.
I like to crush souls. What do they say? Math stands for mental abuse to humans. 1/8 minus 1/2, so 1/8 minus 4/8 would be negative 3/8, and then it'll be at 1. 1/4 minus 1/2 would be negative 1/4. Negative, or excuse me, 3/8, bless you, minus a half would be negative 8. This would be at negative 5. And then 1/2 minus 1/2. 0. I've had enough of you and your bad math skills. Get out of my class. Was it Air Force One? Was that the Harrison Ford one? Get off my plane! It was was it Gary Oldman in that one? I think Gary Oldman was in that one. He was the bad guy in that one. Get off my plane.
Yes.
All right, let's see if I can guess the year. I'm going to say 95? Was it 1995?
1997.
I was close. All right, anyway, so now we have all of our points. We know that we have to move everything down. The lowest value is now going to be at a -5. One thing I want you guys to see is when you have your parent function, obviously everything goes through 0. Where's my new 0 line going to be? It would be down at -2, okay? So, excuse me. We know that this point becomes at 0. So we have, we're at 0, or excuse me, that moved over, so we're at -pi/2, and then we're at -3 pi/8, -pi/4, -pi/8, and back to 0. So we just go through them. We're at -2, we're at 1, -4 back at -2, -5, and to here. And there's our. It's not drawn to scale. And that's the idea. The idea that you can get the ordered pairs correctly is more important than making your graph look pretty. Because a lot of these are just going to look awful. Yes, sir?
And we don't start at -2, we still start at 0.
What do you mean?
So like we in the middle of the graph
Mhm.
where if you started at 0
Oh,
for the left
I'm sorry. Yeah, that should have been, yes, that one should have been at -2. I mismarked it, my bad. Thank you for, I didn't realize I had done that. I moved it over because I knew I was going to wind up at, I was thinking my x value was at 0 when I get to that spot. So that should have been at -2 in here. Okay. You know what? From now on, I'm doing this all in one day. We don't need to do 2 days for this. Waiting, done. I'm going to go have some coffee. It's a mixture of salted caramel and regular old boring Folgers. Yeah, looks close enough. Give me a number.
2.
All right. Do that one. Label everything. I'm going to do this one, then I'll show you how to do the quiz. A, 2, B, 2/3, H. What's your H? Pi/4. It is not -pi/4. And K is 2. Remember, it's always the same K value. It's the opposite sign for H. Gives me an amplitude of 2. A period of, let's see, 2 pi divided by 2 over 3 is what, 3 pi? I'm going to have to move it right pi/4 and up 2. So it'll be x plus pi/4 and then y plus 2. So I'll probably just make this a little bit longer and have it go up a little bit higher. So I start at 0. I end at 3. 3/2, 3/4. So 3/4, 6/4, 9/4, right? Oh yeah, sorry. Yeah, I got to put pi in it. Thank you. A was positive. Cosine. Where does cosine start? Does it start at 0 or A?
Hey.
All right, never mind. A, 0, opposite of A, 0, A. Oh. All right. What is 0 plus a fourth? Uh, 3 pi over 2 is the same thing as 6 pi over 4. So I add a fourth to that and I get 7 pi over 4. What's that? Then 9 pi over 4 plus that'd be 10 pi over 4, which is 5 halves. I know what you're saying. I mean, you should. You're supposed to because fractions are always simplified. So, yes. And then, let's see, 3 pi plus a fourth, so it would be 12, 13 pi over 4. But remember, the fractions, you're not going to get, I was telling this one to 12th hour, you're not going to have fractions you'll have like a fourth and you have to move it 3 pi over 7. Common denominators of 28. That's awful. I'm always going to keep stuff where you don't need a calculator for it. And that just matters moving things around. So when you start doing this stuff and you're moving your stuff, you have pi over 4, here's this. Basically, you know that all of them moved over a fourth. You know that pi over 4 still has to be less than 3 pi over 4. So you just kind of fudge it within where you're at. Does that make sense? And then you know that you have to go up now to 4. So it starts here. This would be at 2. This was our 0, or 2, 4. Oh, I forgot to make my dotted line. I'm sorry. Please forgive me. I'll get over it.
Like having your job.
Them's fighting words, apparently. Yes, as a matter of fact, I do like having What section is this? 14.
Yeah, 14.
Hi, Zoe!
Zoe.
This is Zoe.
Hi, Zoe.
Hey, look, we're graphing sines and cosines. Thanks, Zoe. Let's do. Want to hang out with us? Go back there. Yeah. We might ask you math questions. Those 4 are graphs. The last 2 are write the equation for the given information. Okay? No. Please list out ordered pairs. If you give me a second, I will pull up the PDF file because I don't know if it's already posted. Do you know Zoe? Do you know Carter? Carter, wave to Zoe. Do you know Carter? He's a jerk. He yells at me all the time for forgetting to post like worksheets online, and then he emails me regularly about it, and it's really rude. I'll go back to it. Oh, you got it? Okay. What is wrong? Oh, whoa, that was weird. There you go.